Hey everyone, today we are going to be going over force projection. A lot of people call this the dot product section. I don't like to use that as much because we're actually projecting forces using dot products. So anyway, what I hope to do today is explain a little more about what a dot product is, what it's actually doing, so that you can understand the process behind it. Because what I notice a lot of students do is they memorize how to do a problem and then they can't apply it to other problems because they don't understand it, or they just completely forget how to use dot products after this section is over because don't really understand what a dot product is. So hopefully we can clear that up a little bit today. So first of all, we'll go over what a dot product is and where this equation comes from that we're using, and then we'll go over a simple problem. So the problem states, if we have a bar, just like a bar with a little elbow in it, and a force pulling at the end of that bar, how much of this force is acting along this axis? AO, right here. So basically what we want to look for is the component of the force that is acting along it and the component of the force that is acting perpendicular to it. This may seem a little different than what you're used to, but it's actually the exact same thing you've been doing, except for in 3D. Before, you had something like this. We have a force, and we're trying to find the x and the y components of the force. Well, the x component is exactly the same as the component acting along the axis. You can call this your axis, and then y is the component that's perpendicular to your axis. So you notice it's actually just the exact same thing. And if you have two axes acting at any angle from each other in any orientation in space, there is an angle that you can view them at that they will turn into a 2D problem, right? So let's look at how this relates to a dot product. So if we want to find the x component of this force right here, what we would do is x equals f cosine of theta, right? Okay, now let's look at our dot product. The definition of a dot product is A dotted with B, and I use a little open circle here because it's not multiplication, it's a dot product. A dot B equals A magnitude times magnitude of B cosine of theta. Okay, so we want these two to relate, right? We're going to try to find the parallel component of this force on this axis using this. Well, to get these to look the same, we have to divide A over. So what we're going to do is A dotted with B divided by the magnitude of A, and that's going to equal magnitude of B times cosine theta. Now, A and B are just completely arbitrary terms that we use for this equation. So what I'm going to do is replace B with F. And something really, really important to remember is that a dot product is two vectors dotted together, and the answer that it gives you is one scalar number. Now, if you're having trouble with these terms, magnitude, scalar, vector, position vector, unit vector. I would encourage you to go back to the video called Terms and Vector Addition. I explain a lot of those terms in there and what they are. Anyway, let's keep going. So, if you notice, right here, we have the exact same thing as we have over here. So, doing this right here will give us the parallel component of the force acting on this axis AO. Okay, so the only question now is, what is this A? Well, the A is going to be the position vector of this right here. This A is going to be the position vector of our axis. Okay, and this is going to be the magnitude of the position vector of our axis. Well, what happens when you divide a position vector by the magnitude of a position vector? You get a unit vector. So we're going to say A stands for our axis right here that we're projecting onto. So we also know that A vector divided by A magnitude equals the unit vector of A. Okay, so then what we have now is the unit vector of A dotted with the force vector equals F cosine theta, or our answer that we're looking for, the parallel component of the force. So this force projected onto the axis. So that's half of our answer. That's the parallel component. Okay. Now, hopefully you can remember all this. I do encourage you to memorize the definition of a dot product right here, because if you ever forget how to do these problems, you can come back here and say, oh, okay, I have to divide A over, and then I get this, and you can work it out yourself.